Let us solve some more questions that use the laws of indices and the laws of nth roots. Starting with the first question, you have been given the values of x and y and the relation between x and y. So what is the value of z that is closest to? So we know x raised to z is equal to y square. So I can write x's value is 10 raised to 0.48. So 10 raised to 0.48 raised to z is equals to y is 10 raised to 0.70. So 10 raised to 0.70 raised to 2. So this is according to the law of indices a raised to m raised to n, which is a raised to m times n. So this becomes 10 raised to 0.48 times z, which is equals to 10 raised to 0.70 times 2, which is 1.4. So these numbers are same, so I can equate the powers. So I can write 0.48z is equals to 1.4. Therefore z is equals to 1.4 by 0.48. Rather, I can say 1.40 divided by 0.48, and it is equivalent to 140 by 48. So dividing the numerator and denominator by 2, so I get 70 and 24. Again divided by 2, 12, the numerator becomes 35. So 35 by 12. Now let us divide 35 by 12. So I have 35 by 12. So 12 2s are 24. What remains is 11 point. So 2 point something. So our answer is closest to option number 3. Now let's jump to question number 2. If m and n are whole numbers such that m raised to n is equal to 121, then what is the value of this expression? Well, let us write what has already been given to us, which is m raised to n is equals to 121. Well, you know what is 121. 121 is the square of 11. So I can write 11 square is equals to m raised to n. So therefore m is 11 and n is 2. We know the values of m and n. We can put it in this expression and get the answer. So m minus 1. So 11 minus 1 raised to n plus 1, which is 2 plus 1. That is equals to 11 minus 1 is 10 raised to 2 plus 1 is 3, and that is 1000. 10 raised to 3 is 1000. So our answer is option D. Moving on to the third question, what do you think is the answer of this big expression? So I can see most of the terms as 3. So let us convert all of these terms to powers of 3. So 243 is the fifth power of 3. So I can write this as equal to 243 is 3 raised to 5. So 3 raised to 5 raised to n by 5 times 3 raised to 2n plus 1 divided by 9 is 3 square. So 3 raised to 2 raised to n times 3 raised to n minus 1. This is equivalent to 3 raised to a raised to m raised to n is a raised to m times n. So 3 raised to n by 5 times 5 into rest of the terms are as they are divided by 3 raised to 2n times 3 raised to n minus 1. Now in the numerator I have a raised to m times a raised to n, which is a raised to m plus n. So 3 raised to I can have, well, let us cancel 5 here. So I have n plus 2n plus 1. So n plus twice of n plus 1 divided by, again the same thing in the denominator. So 3 raised to 2n plus n minus 1. So 3 raised to 2n plus n minus 1. So this is equal to 3 raised to 3n plus 1 divided by 3 raised to 3n minus 1. Now I have a situation where I can again apply a law, a raised to m divided by a raised to n, which is a raised to m minus n. So this is equivalent to 3 raised to 3n plus 1 minus of 3n minus 1. So this is equal to 3 raised to 3n plus 1 minus 3n plus 1. So 3n and 3n get cancelled out. What remains is 3 raised to 1 plus 1 is 2. So 3 square, and that is 9. So the answer is option C. Now time for the final question. What is the number of prime factors in this expression? Well, let us express all of these numbers as a product of their prime factors. So I can write 216 as 6 cube. 6 cube is 216. So 6 cube raised to 3 by 5 times 2500 is 50 square. So 50 square raised to 2 by 5 times 300 is 3 times 10 square. So it is 3 times 10 square raised to 1 by 5. So this is equal to 6 is a product of 2 and 3, which are prime numbers. So 2 times 3 whole cube. So I can write it as 2 cube times 3 cube raised to 3 by 5 times, again I can write 50 as 5 times 10, and there's a square there, so I can write 5 square times 10 square raised to 2 by 5 times 3 times 10 can be written as 2 times 5. So 10 square is 2 square times 5 square, and I have the power there raised to 1 by 5. So this is equals to, we can simplify it as 2 raised to 3 times 3 by 5. So 2 raised to 3 times 3 by 5 multiplied by 3 raised to 3 times 3 by 5 times 5 raised to 2 times 2 by 5 multiplied by 10 raised to 2 times 2 by 5, but 10 can be written as, let us simplify it later, let us keep it as it is. So 10 raised to 2 times 2 by 5 times 3 raised to 1 by 5 times 2 raised to 2 by 5 times 5 raised to 2 by 5. So this is equivalent to 2 raised to 9 by 5 multiplied by 3 raised to again 9 by 5 multiplied by 5 raised to 4 by 5. 2 times 2 is 4 multiplied by 10 can be written as 2 times 5. So I have, basically this is 10 raised to 4 by 5, and 10 raised to 4 by 5 can be written as 2 raised to 4 by 5 times 5 raised to 4 by 5 multiplied by 3 raised to 1 by 5 times 2 raised to 2 by 5 times 5 raised to 2 by 5. Well, this is getting out of control, I think. Let us simplify it further. So I have the 2 common here, and all of these terms are multiplied with each other. So I can write 2 raised to 9 by 5 plus 4 by 5 plus 2 by 5. So by 5, 9 plus 4 plus 2. 9 plus 4 is 13, plus 2 is 15. So 2 raised to 15 by 5 times, let us take the 3's here. So 3 raised to 9 by 5 plus 3 raised to 1 by 5. So 3 raised to 9 plus 1 is 10. So 10 by 5 times, I have the 5 here. So 5 raised to 4 plus 2 is 8 plus 2 is 10. So 10 by 5. Now things are coming under control. So I can write this as 5 times 3 is 15. So 2 raised to 3 times 3 raised to 5 2s are 10. So 3 raised to 2 times 5 raised to 10 by 5 is 2. So there are these much of prime factors. So the total number of prime factors is 3 plus 2 plus 2, and 3 plus 2 plus 2 is 7. So the total number of prime factors are 7 in this expression.